Hi chemistry community. Today I'm gonna do a video just doing a lot of examples on how to name coordination compounds, just because I know that I had a lot of trouble with it at the beginning, and I think just like the more you practice, the better you get. So, yay! Also, even if I thought I knew how to do the coordination compound thing, because I read the course reader, when there are like more complicated examples that came up in like the homework or like a quiz or a test, then I would not be able to do it because I'd never seen them before. So I think the best way to get good at naming coordination compounds is just to like experience solving as many different ones as possible, because you never know. Okay, so let's start with an easy one. So Fe, cyanide 6, and then the overall charge is -4. So first off, we know that it's going to be an ion because there's an overall charge in the bracketed things. And then next, determine the transition metal to which the ligands are bound, and then that's Fe, or iron. And then this should be cyanide, and then this is the only ligand, but there's 6, so it'll look something like Fe, and then each one should have a cyanide. So we know that the ligand name should come first, and then the prefix should be reflect the number of ligands. So this is 6, so it should be hexa, and then this is cyanide, and then we know that ligands, the name sort of changes when we put it in the name. So instead of cyanide, it should be cyano. And to figure out the charge on the Fe, we should look at the other charges and try to determine how it adds up. So cyanide is a -1 charge on each ligand, and then there's 6 of them, so it's a -6 charge for all the cyanide. And then, but the overall charge is -4, so something has to change this -6 to a -4, which means that this iron should be a +2, because +2 minus 6 equals -4. So if we start with the ligand, it should be hexacyano. And then in a different case, we could write iron, but because there's an overall charge on the ligand, it means that we can't just write iron for this. We have to write the Latin for it. So it would actually be ferrate. So it would be ferrate. And then we add the charge, which is 2. And then because it has a negative overall charge, it should be ion. So the final name for that would be hexacyanoferrate ion. And remember that there should be no spaces. And another thing to just make sure you understand is that we use ferrate instead of iron because the coordination compound had an overall charge of -4. So if it's negative, then we always add an ATE to the end of the metal name, or in this case, the Latin root for that metal. Okay, so the next one is, I think, a little easier. Let's name the transition metal. It's cobalt. This coordination compound is also hexadentate, like the previous example, because there's 6 ligands that attach to the central one. So it would also look like this, with each one having an amine ligand on it. So we have the cobalt in the center, and then 6 amines, so it would be hexa, like the previous example, hexaamine. And then the overall charge would have to be, for cobalt, it would have to be like +3, because amine is a neutral ligand, so there's nothing else that could provide the +3 charge except the cobalt. Therefore, the overall name would have to be, since the ligand comes first, it would be hexaamine, and then add the cobalt. Notice here that it doesn't become cobaltase because it's a +3 charge and not a negative charge overall. And then 3. And then because there is an overall charge on the coordination compound, it would have to be an ion. So the final is hexaamine cobalt 2 ion. Yay! Okay, our next example is COCN5OH2 -2. Okay, so the central transition metal is cobalt again, and then our ligands, we actually have 2 different ones this time. This one is cyanide, we've seen it before, but okay, maybe it's just because I'm dumb, but I guess I wasn't paying attention in class because when I first saw this, I was like, oh, I don't know what this is. But it's actually just H2O, so don't be confused like me. So cyanide has a charge of -1 per ligand, so the total charge is -5 here. And then water, or aqua, for its ligand name, is a neutral. And then the overall charge is -2. So to make -5 and -2, we would have to make the cobalt +3. And remember that when you have more than one ligand, we have to put it in alphabetical order, but the alphabetical order comes before it depends on the actual name of the ligand and not the prefix for the charge. So for water, the ligand name would be aqua, and then cyan would be cyano, but there's 5, so it would be pentacyano. And if we put that all in order, it would be aqua, and then pentacyano, cobalt, but remember when we have an overall negative charge on the coordination compound, it actually has to turn into, you have to add an ATE. So it would be cobalt 8, and then the charge on the cobalt is a +3. So we add 1, 2, 3. And then because there's an overall charge on the coordination compound, we have to add ion. So the final name is aqua pentacyano cobaltate 3 ion. A harder last example because I don't want to waste people's time if the previous ones were too easy. So this one has an element attached to the side, but not actually in the coordination compound because it's outside the brackets. The transition metal is iron, and then there are 2 different ligands. So this one is aqua, and then this one is C2O4, which is oxalate. It doesn't have an overall charge, so it wouldn't have the ion that we had for the previous examples. So let's just get this sodium out of the way. At the beginning of the coordination compound name, it would just be sodium. There's a 2 here, so it would be a di-aqua. But remember that the ligands are named by alphabetical order according to the ligand name, so the A, not the D in di. C2O4 is oxalate. But remember that this is a ligand name, so it would be converted to oxalato. And also, although there's a 2 here, so it should, like, you would think automatically that this should be a dioxalato. However, it's sort of awkward to say that because this is already you would actually just add a bis instead of a di because it's not like a regular ligand. It has a Greek or Latin root. So it starts with a Greek or Latin root, so it's sort of weird if you add a di. The charge on the Fe, because oxalate has a -2 charge per ligand, it would actually be a total of -4. Aqua is neutral, so here we have -4, and then the Na is providing a +1 charge, so the other +3 should come from the iron. So it would be sodium, and the next alphabetical order one would be aqua, so sodium diaqua, and then bis oxalato, and then the ferrate would come last. So, and the reason why this is ferrate is because although the overall thing has a neutral charge, if we took out the Na, which is not actually part of the coordination compound, it would actually have a -1 charge here. So don't be tricked by the fact that there is no number at the top right corner, because you have to consider that there are other elements that are providing charges. And because iron has a +3 charge, it's a +3, but at the same time we don't have to write iron because the overall compound does not have a plus or negative charge on it. So yeah, that was my video. I'm sorry it was sort of long. I hope it helped someone, in at least one person, in trying to figure out how to name coordination compounds. Good luck on finals next week, and yeah, go Chem Fortuné!